So in section 8.2, we're going to essentially learn how to solve systems of equations using tables that we call matrices. A matrice is essentially just a table. Usually I fill up the table with numbers. Let me just draw some pictures before I get started. This would be an example of a matrix. Matrice is plural of matrix. If I just did 1, 2, 3, 4, 5, 6. This matrix going horizontally, I call these rows. So I would call this row 1 and row 2. So 4, 5, 6 makes up row 2, 1, 2, 3 makes row 1. Vertically, we look at the numbers as columns. So I would say column 1 has the entries of the numbers 1 and 4. Column 2 has the numbers 2 and 5. Column 3 has the numbers 3 and 6. This matrix, I would say, is a 2 by 3 matrix because it has 2 rows and 3 columns. In our section 8.2, we are going to solve systems of equations using matrices, and let me just jump into it. So what we're going to do is take a system of equations, create a matrice to solve that system of equations, and then manipulate the matrice to get the answer to the system by using something called row operations. So in the world of systems of equations, if I was asked to solve this, I would probably use the elimination method to solve this because it's, for me, the easiest way to solve. But there's a lot of creativity when it comes to solving with the elimination method or even the substitution method that we did in the last section. Specifically, there are multiple ways to get the answer. They all could lead to the same answer. The process isn't quite as regimented. In this section, I'm going to develop a very regimented process to go from the answer, from the problem to the answer, following very specific steps. And because the steps are so specific, you can program technology, some sort of computer, to do this work relatively easily because there's no creativity. So let me just jump into solving the problems using matrices to solve systems of equations. So I'm going to solve the problem 5x minus 3y equal to 9, the system of linear equations, 5x minus 3y equal to 9 and 2x plus 7y equal to 7. First, I'm going to strip off the x, the y's, and the equal signs and create a matrix solved by the systems of equations. So I'm going to just pull off the coefficient of the x in the top equation, 5, the coefficient of the y in the top equation, -3, and the number to the right of the equal sign, 9. Create a top row of a matrice, and then the numbers 2, 7, and 20 will be the bottom row of my matrice. This, I say, is a skeleton representation of that. Often, I put a bar right here separating the sides with the x's and the y's from the equals. So this right here, it means this top row means 5x minus 3y equal to 9, and the bottom row means 2x plus 7y equals to 20. This is the matrix representation of that system of equations. The numbers in the first column represent x's, the numbers in the middle column represent y's, the number in the far right column represents numbers that are to the right of the equal sign. So now we're going to use the elimination method very carefully. So this is step 1. I created a matrix implied by the system of equations. I need to reduce this so I can read off the answers. And how do I do that? Well, I'm going to use the elimination method first to eliminate the x's. How do I do the elimination method? Well, if I want to eliminate the x's, I want the numbers in front of the x's to have the same number, opposite signs. So what I'm going to do is I'm going to make one of the x's have a negative 10, the other of the x's have a positive 10, so I could eliminate the x's. It'd be easier to do just from here. Multiply the top equation maybe by -2, the bottom by 5, and eliminate the x's. And that's essentially what I'm going to do, except I'm doing it with the stripped down matrix version. So I'm going to multiply the entire top row by -2. I'm going to go -2 times 5 and get -10, -2 times -3 and get +6, -2 times -9 and get -18. That makes the x in the top row have a -10 in front of it. Bottom row I'm going to multiply by 5. 5 times 2 is 10, 5 times 7 is 35, 5 times 20 is 100. Then I'm going to add these together, just like I'm doing the elimination method. It's exactly the same as doing the elimination method, except instead of having, -10x plus 6y equals to -18 and 10x plus 35y equal to 100, which is what I would get if I was using the elimination method to drop out the x's, multiplying the top equation by -2, multiplying the bottom equation by 5, and doing exactly the same algebra, but doing it without the x's and y's and without the equal sign. So top by -2, bottom by 5. Now I'm going to add these together. If I added these together naturally, I would cancel these out and get 41y. I'd get 41y equals to 82. That's essentially what I'm getting here, but I can't drop out the x like I could when I'm dealing with variables. With matrices, I can't. I need a number in every spot. So I'm going to add -10 plus 10. That cancels out my x's. 6 plus 35. That gives me 41 from front of my y's. And the numbers here have opposite signs, so I subtract and get the sign of the larger. So this is the end of my step 2. Essentially got that, except I need to have the 0x tossed in. And before I move on, I'm going to divide all these numbers by 41, because this is exactly what I would do if I was doing the elimination method. I would divide both of these by 41, and I would get y equal to 2. Exactly what I'm getting right here, except in the world of matrices, I'm not allowed to drop out that x. I'm going to divide that by 41 as well. Idiot. So step 3, divide away the common factor. I'm going to divide away the 41. I'm going to go 0 divided by 41 is 0. 41 divided by 41 is 1. That's the number in front of the y. 82 divided by 41 is 2. This now is going to become the bottom row in my matrix. So the bottom row in my matrix is going to be 0, 1, 2. Not that it's necessary, but right now the top row of my matrix still says 5x minus 3y equals to 9. The bottom row of my matrix now says 0x plus 1y equal to 2. The bottom row of my matrix really just says y equal to 2 because of 0x is nothing. So done with step 4. So all I've done is use the elimination method but kept things in matrix mode, which makes it just a lot more tedious to do, but not particularly hard. There isn't anything new. Step 5, I'm going to eliminate the y's now. So what I need to do is look at this system of equations, which is, what that is equivalent to, and drop out the y's. Well, how would I drop out the y's? I'd get the same number with opposite signs. So I'd multiply the bottom by 3 to drop out the y's, and I would get 5x minus 3y equal to 9, and 0x plus 3y equal to 6. Add these together. This would give me 5x equals 15. I would divide by 5, and get x equal to 3. This is exactly what I'm going to do, except I'm doing it without the variables. So I'm going to take this system of equations, which is equal to that matrix, and drop out the y's. This is my y column. How do I drop out the y's? I drop out the y's by getting the same coefficients with opposite signs. So I'm going to multiply the bottom row by 3, just like I multiplied by 3 here, and I left the top row unchanged. So I'm leaving the top row just how it is, and then the bottom row, I go 3 times 0 is 3. 3 times 0 is 0. 3 times 1 is 3. 3 times 2 is 6. And now I can add these together. 5 plus 0 is 5, just like here. And then negative 3 plus 3 is 0. Here I didn't write the y's, but in matrices you can't just drop out a variable. And 9 plus 6 is 15. So this is basically this. This 5x equal to 15 is just because I didn't write this 0y. I could have written this 5x plus 0y equals to 15. The 0y is not necessary. But in matrices, you can't drop out a variable. So that's the end of step 5. Now I'm going to divide away the common factor. 5, 0, and 15 are all divisible by 5. So I did 5 divided by 5, 0 divided by 5, 15 divided by 5, just like I divided by 5 there. It's nothing different. It just looks way more complicated. And this 5 divided by 5 gives me 1. 0 divided by 5 is 3. 0 divided by 5 is 0. 15 divided by 5 is 3. I'm going to make this answer the top row of my matrix. Basically done now. Now I could write my answers down. I took the extra step to write down what this top row is as an equation. It's 1x plus 0y equal to 3. And the bottom row represents 0x plus 1y equal to 2. Of course, the 0 parts can be stripped away. This really says 1x equal to 3. This really says 1y equals to 2, or x equal to 3, y equal to 2. I have my answer. And just like in the last section, we can check. How do I check? I go to the original problem, plug 3 in for x and 2 in for y for both equations, and make sure it simplifies to something true. This is what we need to do for this section. Let's do a problem together, following all these ridiculous steps. So, for problem 2, let me solve this using matrices. Step 1, let's create my initial matrix. So, for step 1, I'm just creating a matrix. And the matrix is just going to have the coefficients 8, negative 3, and the numbers to the right of the equal sign, negative 2, and 2, 1, and negative 4. So I just stripped off the coefficients of the variables and the numbers to the right of the equal sign and made up my matrix. I often put a vertical bar here separating the x, the y's, and the equals, but it's not necessary. And I can't do it on Word. Word doesn't even think it's important enough to make it available to me. That's the end of step 1. Now I want to eliminate the x's. So step 2, I'm going to eliminate the x's. And how do I eliminate the x's? Well, I get the same number with opposite signs. Right now the x's have an 8 and a 2. I'm going to create a negative 8 in the bottom to make this canceling happen. So I'm going to leave the top at 8, negative 3, and negative 2, and I'm going to multiply everything in the bottom by negative 4. I'm going to go negative 4 times positive 2 and get negative 8. That's going to make my x's eliminate. Then negative 4 times positive 1 and get negative 4. And then negative 4 times negative 4 and get positive 16. This is exactly the elimination method, except we're stripping out the x, the y's, and the equals. So now I'm going to add these together. 8 plus negative 8 is 0. Negative 3 plus negative 4 is negative 7. Negative 2 plus 16 is positive 14. That's the end of step 2. I've eliminated my x's. Step 3, divide away the common factor. And what I'm going to do is take everything and divide it by -7 as opposed to +7. There's a common factor of 7. The y has a negative in front of it. It's probably better to do that because this right here as an equation is 0x minus 7y equals to 14, or really minus 7y equal to 14. And if you were solving that, you would divide by -7 and not the positive. So doing that division, I get 0, +1, and -2. That's the end of step 3. Moving on to step 4, I'm making this my new bottom row. So that initial matrix that I created, I'm not going to toy with the top row just yet. I'm going to leave it at 8, -3, and -2. But this work, I'm going to make my new bottom row. Done with step 4. So step 1, create my matrix. Step 2, eliminate the x's. Step 3, divide away the common factor. Step 4, make a new matrix. Step 5, now I'm going to eliminate the y's. And you can condense these down to way less steps. How am I going to eliminate the y's? Well, the y column's the middle column. I need the same numbers with opposite signs in front. I'm going to multiply this bottom row by 3 to get a +3 to cancel with a -3. So by eliminating my y's, I'm going to make the top row unchanged. And I'm going to go 3 times 0 is 0. 3 times 1 is 3. There's the elimination of my y's. 3 times -2 is -6. So this is step 5. Add together. 8 plus 0 is 8. -3 plus 3 is 0. -2 plus -6 is -8. That's the end of step 5. Step 6, divide away the common factor. Common factor is 8. So divide by 8, divide by 8, divide by 8. This is going to give me 1, 0, and -1. Done with step 6. Make the answer to step 6 my new top row. So in this matrix that I'm working with, for my step 7, I'm going to make this row 1, 0, -1 into my new top row. And I'm not changing the bottom row of 0, 1, and -2. I'm basically done. It's going to be x equal to -1, y equal to -2. At this point, it's almost silly what I'm doing, but just to emphasize this, because sometimes it's not clear to students, but if you can pick off the solutions, you don't need to do these last few steps. This step 8, says create the equations implied by the top row and the bottom row. The top row means 1x, because this is the x column, plus 0y equals -1. The bottom row as an equation is 0x plus 1y equals -2. I don't need the coefficient of 1 in front of the x, and the 0y cancels out to be 0. I don't need the coefficient, the 0x is 0, I don't need the coefficient of the y in the second equation. And there's my x equal to -1, y equal to -2. I could check, but I'm trying to keep this video a sane length, so I'm not going to check this, and I'm just going to say that's the answer. Let's do a few more of these. Eventually, they're not that hard. They're just tedious to beyond, beyond belief, but not particularly hard. So, problem 4. Let's do this with matrices. First step, write the matrix that's implied by the system of equations. So step 1, create the matrix. I'm going to have 5, 2, and 16, 1, -7, and -19. Step 2, so this is just create the matrix. I have an x column, a y column, and an equal column. Step 2, I'm going to eliminate the x's. And of course, if you're doing the elimination method, hopefully it's obvious that you'd multiply this by -5 to cancel out the x's, because you'd have both a positive and a -5x. That's exactly what I'm going to do. I'm going to multiply the bottom row by -5 to force the x's to cancel. I'm going to leave the 5, 2, and 16 row intact. And then from the bottom, I'm going to go -5 times +1 is -5. -5 times -7, +35, -5 times -19, just dumb to do that in my head. -5 times -19 is +95. Add together, get 0, 37, and 111. So in step 2, this is what I have, 0, 37, 111. Step 3 wants me to divide away. And it's always going to divide the number in the y column here. So I'm going to divide by 37, divide by 37, divide by 37. Most of the division I could do by myself, but 111 divided by 37, I can't do, and I get 3. So the division is going to give me 0, 1, and 3. Done with step 3. Step 4 is to create a matrix with this as its bottom row. So I'm leaving the 5, 2, and 16, and I'm going to add to it 0, 1, and 3. Done with step 4. On to step 5, which is eliminate the y's. This is my y column. To eliminate the y's, I need to get the numbers in that column to be opposites. To do that, I'm just going to multiply the bottom row by -2. I'm going to leave the top row at 5, 2, and 16. And then for the bottom, I'll go -2 times 0 is 0. -2 times +1 is -2. -2 times 3 is -6. This is going to give me 5, 0, and 10. That's the end of step 5. Step 6 is to divide. If I could actually spell it. I'm going to divide this by 5, that by 5, and that by 5, and get 1, 0, and 2. Step 7, I get a new top row. So for this matrix, its top row is now going to become 1, 0, and 2. And I'm basically done at this point. I don't really need to do anything else. I can read off my answers. But step 8, if you really want to get precise, the top row really says 1x plus 0y equals to 2. The bottom row says 0x plus 1y equal to 2, taking the x's, the y's, and the equals. Top row gives me 1x or x equal to 2. Bottom row should be equal to 3. I just didn't write it down right. The bottom row says 1y or y equal to 3. And then my answer is x equal to 2, y equal to 3. Next step would be to check. Let me try to do one more of these, and then we'll just call this section over, even though maybe there's more problems to do. But I think 3 of these should be sufficient. And let's try to go through problem 6. So problem 6, step 1, create the initial matrix. So step 1, the initial matrix is going to be 4, 1, 11, 3, -5, 37. Step 2, eliminate the x's. Even though it would be tempting to eliminate the y's because it would be easier, there's an order that you should follow. So to eliminate the x's, I need the x's to have the same number opposite signs. I'm going to multiply the top row by -3, the bottom row by 4 to get a positive and -12 in front of my x's. So -3 times 4, -12, -3 times 1, -3, -3 times 11, -33. Bottom row, 4 times 3, 12, 4 times -5, -20, 4 times 37, 148. 12 and -12 cancel. -3 plus -20 is -23. And -33 plus 148 is 115. That's the end of step 2. Step 3, divide. What am I going to divide by? I'm going to divide by the number in the y column. I'm going to divide by -23, -23, -23. First division, 0 divided by -23 is 0. Second division, -23 divided by -23 is 1. Last division, I get 115 divided by -23 is -25. Step 4, I get a new bottom row. So my top row stays at 4, 1, and 11. My bottom row becomes 0, 1, and -5. Step 5, eliminate the y's. These aren't particularly hard to eliminate. I'm just going to get opposites, and it doesn't matter if you multiply differently than me, you'll get the same work. I'm going to multiply there by -1. I'm going to leave the top row 4, 1, and 11, and then I'm going to go -1 times 0 is 0, -1 times 1 is -1, -1 times -5 is +5, and add 4 plus 0 is 4, 1 plus -1 is 0, 11 plus 5 is 16. So that's my step 5. I've eliminated the y's. Step 6 is to divide. I'm going to divide by 4, divide by 4, divide by 4, and get 1, 0, and 4. Step 7 is to make my new top row. So for this matrix, the top row now is going to be 1, 0, and 4. The bottom row is going to stay at 0, 1, and -5. Step 8 is to create my equations. And if you get the answer without this, don't do this. Top row would say 1x plus 0y equals to 4. The bottom equation would say 0x plus 1y equals to -5. Top row gives me x equal to 4. Bottom row gives me y equal to -5. And so step 9 is to write my answer. And my answer is x equal to 4, y equal to -5. And then let me check this just to show you. Not that you can see the original problem. The original problem is 4x plus y equal to 11 and 3x minus 5y equal to 37. So the checking would make sure that 4 times 4 plus -5 equals 11, and 3 times 4 minus 5 times -5 equals to 37. So top checking, 4 times 4 plus -5, you get 11 equal to 11. Bottom checking, 3 times 4 minus 5 times -5 and you get, oh, I didn't write a 3. 3 times 4 minus 5 times negative 5, and you get 37 equal to 37. So there isn't anything new, and we're at 30 minutes. I don't feel like I need to do a part 2 to it would be exactly the same. So we're just going to go through each one of these steps for each problem. First, take the system of equations, create a matrix. Second, eliminate the x's. After you eliminate the x's, there's probably going to be division that you can do. Do the division, make a new matrix with a new bottom row. From that new matrix, when we move on to step 5, eliminate the y's. Divide to make a way that get rid of the common factor. Make a new matrix with this as its top row. Create the equations and write your answers. But usually once I get to here, I can write my answers. I just pull the numbers off the far right column, and those are going to be the answers in order. So hopefully this was not so bad. Let me know if you think I need to make a second part to this video, and I can do more problems because I've only got up through problem 6, and there's a handful of problems. Kind of supposed to get up through number 12. If you don't need that many examples of this, if you don't need to do 6 examples of this, stop at 4 of these. And if you feel like you could master these without doing every problem, that's good too.